If you are a high school student and learning mathematics, you might have come across this formula, which is Euler's formula. And your professor might have told you that the derivation of this formula is related to Taylor series, and most of the high schools doesn't cover up Taylor series in the early semesters. So it is quite difficult for early semester students or early year students to figure out how this formula came into existence. But in this video, we are not going to use Taylor series. In fact, we are using just some integrals and derivatives to figure out the actual formula. So without any further ado, let's get started. So let's suppose that z is equals to cosine of theta plus iota sine of theta, and by differentiating both sides with respect to theta, we will have dz over d theta is equals to minus sine of theta plus iota cosine of theta, which can be rearranged into iota cosine of theta minus sine of theta. Observe that here we have minus sign, which I can replace it from iota square, positive iota square. So we will have iota cosine of theta plus iota squared sine of theta, and we can take iota as a common factor here. So we will have iota times cosine of theta plus iota sine of theta, and this cosine of theta plus iota sine of theta is nothing but z. So we will replace it with it, and we will have dz over d theta is equals to iota z, and by cross multiplication we will have dz over z is equals to iota d theta. And now we have came to the part of integrating both sides. So we will have integration 1 over z dz is equals to iota will be out of the integral because it is a constant, and inside the integral we will have d theta. So by integrating both sides, 1 over z will be ln of z, and d theta will then be iota theta plus some constant c. Now by taking e on both sides, we will have e raised to the power ln of z is equals to e raised to the power iota theta plus some constant c. Notice that e and ln are both opposite of each other, so they will be cancelled out. So we will have z is equals to e raised to the power iota theta, and is separated by e raised to the power c, which can be written as z equals to e raised to the power iota theta and some constant capital C. Now we will have to figure out the value of c, which can be done quite easily. As you can see that by plugging in value 0 in z, we will have 1, and in e raised to the power iota theta we will also be getting 1. So simply c will be equals to 1, and we can say that z is now equals to e raised to the power iota theta, and we know that z was cosine of theta plus iota sine of theta, so we will just have to replace it with it, and we will have e raised to the power iota theta is equals to cosine of theta plus iota sine of theta, and hence our formula, our Euler's formula, has been proved. So I hope you liked the video, so give it a thumbs up, and I'll see you next time.